So this talk, not technical in, let's say, in the conventional sense of what we normally mean by technical talks, but it's more a reflection on the effects of what we do. Let's say, in general, digital technology on humans and society, and which brings to the notion of the responsibility that we have in what we do. So when I talk about digital technology, actually what I mean is software, because this is the real thing that makes the whole difference. And so what I want to do then is to discuss a little bit, or start a discussion actually on how what I'm saying here can lead us to rethink what we do in research and in education. Okay, I would like to start with a brief historical perspective. As people get old, they like history more and more. I like history a lot. Okay, and as an Italian, of course, you have to refer to someone in Latin. And this is, what Cicero said, that the importance of history. So history is not something, is something that really helps us understand where we are. So let's talk about this. What I want to place what I'm saying is in a bit of, understanding of where we are. What is the progress of science and technology? Okay, and I want to refer historically to a very important piece of work that was done by a philosopher, by Thomas Kuhn, in 1962. So Thomas Kuhn is a philosopher of science, and what he actually said and taught is that science and technology undergo periodic revolutions that he calls paradigm shifts, which are followed by what he calls normal science. So the developments of science is through big changes and then kind of normal science, big changes, normal science, and so on. Okay, so the big change is, for example, in physics, when relativity theory was proposed, which was followed by, a lot of normal science, which tries to enlarge, the scope of the central paradigm that was proposed. But the other important thing is that it has also been discovered over and over that the revolutionary changes in science and in technology also lead to revolutionary changes in society and in human life. And if you want, the mother of all revolutions is, something that you have to go back to the early 17th century with the invention of the scientific method. So that was the mother of all paradigm shifts. Okay, because from then, a lot of them happened. When we're talking about the scientific method, we of course refer, to people like, Francis Bacon, Copernicus, Galileo Galilei, of course, Descartes, Newton, and there's many others that I'm not mentioning here, which actually the invention of the scientific method, which was this paradigm shift, then, gave rise to the explosion of modern science. Physics, mechanics, thermodynamics, chemistry, later on electricity. And this, if you want, led, I was saying that, those paradigm changes in science lead to major changes in society. And, of course, the major change there, which occurred over 2 centuries, also due to the other steps of the revolution, which was basically the invention of machines. this is a picture of the the 1700s in the UK, with the textile industry that was born because of the because of the scientific revolutions which led to the industrial revolution. Now, those revolutions are disruptive in the sense that they change society and human life. For example, people lived in a world that was based on agriculture, farming, craftsmanship, commerce, and the world became the world of factories, of machines, of finance eventually. People used to live in the countryside. They moved to cities because, the firms, the labor was in the big cities. The machines were in the factories in the big cities. The world moved from feudalism to capitalism. So the notion of ownership of the means for building, with the machines, of building goods. And, I'm making the whole thing short. If you haven't read this book, I strongly recommend that you should read it. This guy is an excellent historian. And in this book, he talks about a brief history of humankind, and in particular, he actually shows that the progress that humankind made since the invention of the scientific method that we mentioned before in the early 17th century, the progress of humanity was much more than what happened in the previous millennia. So what the previous millennia led, where the previous millennia led humanity, was much less in terms of progress than what happened since the invention of the scientific method and all these revolutions that affected society. Okay, now, long story, let's talk about the digital revolution. My claim is that, and actually I'm not the only one, that the digital revolution is even more disruptive than the industrial revolution. And to understand why it is more disruptive, I propose that we examine 3 dimensions that I call breadth, depth, and speed. Breadth means that all aspects of society are affected. There's no area of our society that is not affected. So this brings to the notion of breadth. Depth means that the changes go to the essence of the processes that are affected by the technology that we produce. They are not at the surface, but they touch the heart of all these aspects. Speed is what I said before. There's an unprecedented change rate. The change rate was centuries. The industrial revolution in for example, from steam engines to electrical engines, it took 100 years, more than 100 years. The speed of what is happening now is in decades. So that gives you the notion of the difference that we have today. So what happens today is that actually we are living in a different world. We are living in a world where humans interact with the physical world that is made, of real things and cyber entities that are more and more autonomous. So it generated a new notion of space in which we live, and also a new notion of time. Time and space are completely different. So we live in a new world. And the boundary between the physical and the cyber is disappearing every day. So what makes them special? here, I want to tell why. So why is this? What are the reasons why digital technology are so disruptive? Well, first of all, there's the physical machines. So everything is based on machines, right? So we have the physical machines for sure, the hardware. We have the interaction among those machines because single machines, are not enough. But we have collections more and more through networking. We have the ability to interact with the world, through with humans, but also with the physical, through sensors, actuators, all forms of human-computer interaction kinds of devices. And this is, again, why, the central thing, however, is software. And the reason why, we all know this, but, sometimes we have to step back and think. The real point here is that, the machines that humans built until today, they were all different. Now, the machines are all based on the same hardware, but, through software, we are able to build universal machines, which we can apply in every domain. Okay? So the software thus becomes the center of delegated responsibilities for the new world because of that. Okay? So there's huge amount of responsibilities that we are assigning to the software that we build. And this notion of responsibility, I think, is key. And I want to, to discuss this with you more and more. So this notion of responsibility. So the evolution has been, the disappearing boundary, as I said. We live in a new world. We don't have technology here and the word there, but actually technology disappears in the world. Okay, and we come to the important concept. I think designing technology, in a sense, becomes more and more designing society, and if you want, even more, designing the world. Designing, not only designing the relations among humans, which is society, but also designing the world, the whole thing. So this, if you go back to history, I mean, the very beginning of this type of thinking goes back to, the work that was done in the 1990s at Xerox PARC, in particular by Mark Weiser, who was the first one to speak about disappearing technology. Okay, so digital technologies, for sure, give us unprecedented opportunities, but digital technology also give us unprecedented threats. And I'm just mentioning some. Privacy violations, biased decisions, echo chambers, people surveillance, platforms and sovereignty. So we live in a world in which, where is the power? Who owns the power to rule the world? It's in the platforms, not so much in governments. And what I want to discuss also with you here is what's happening today. All the other things were here even before. But what is happening today is that through generative AI, we are shifting more and more from automation, automating things, to autonomy. So the things that we develop become autonomous. And this is different. Automation and autonomy, they're different things. You can automate things and control. You can delegate, and you can generate autonomous entities that behave as, autonomous entities. So why should we care? So as I said, software technology creates the word. And so one of the questions that we have to ask is the following one. Are technological skills enough to make decisions on what technology should do? If we buy, what I'm saying, that technology is creating the word, is the competence in producing technology all that is needed? Or is economy, the market, responsible for those decisions? Governments, who is responsible for that? Are we still in charge? Humans. So is the way we do research and education leading to responsible creation of this word? I think this is a question that we have to ask ourselves. And so I'd like to discuss those. And then, what can we do? Can we make technological developments, make them aligned with human and societal values and goals? Are they? I don't think so, but can we still try to align them? And if this is what we want to do, how does this affect research and education? Okay, so why should we care? I already mentioned this, so I'm revolving around this idea that the word exists through software. And I want to show you that actually, this idea is not new. It goes back, I will show you, to a famous book. But the notion is that actually code is the regulator of the space that we are building. So the new word that we are building is regulated by what? Well, it's regulated by software. So software is the regulator. I don't know how many of you have seen this book, but this is a very interesting book. Actually, the author is Lawrence Lessig. He is a professor at Harvard. He was behind also the, in terms of legal aspects, the free software movement. So he wrote this book in the 90s, actually, in which, for the first time, he points to our attention the notion that software is what defines the law of the world in which we live, which is something that we rediscover now, mostly because of the discussions around AI. But it's not just the AI. The AI brings new problems to the table, for sure. Okay, but the notion that software is what defines the world in which we live goes back to the pre-AI reflections, and in particular the work by Lawrence Lessig. Okay, now, so if those laws are in the software, who is responsible for those laws? Who is accountable for those rules? Well, if you go back, to traditionally, how do societies define the rules of the world in which people live? Well, they go through deliberations, human processes. There's democracy in many places through which, people reach a consensus on what should be done. So there's participation of citizens in the definition of those rules, right? Responsibility is kind of clearly defined then by the rules. But what I'm saying is that if you look at the digital world, all this is actually blurred. Who decides those rules? Do we decide them as citizens? Have we ever been asked, to participate in a democratic process that leads to the definition of those rules? So the notion is that there's, what people call an epistemic opacity of the software-defined world. There's a lot of opacity, which is epistemic means, dealing with the knowledge that we have about this world. There's a lot of opacity of what are the rules, what are the behaviors, are due also to the complexity of the software that governs the world. Software is extremely complex, and complexity leads to opacity. So it's hard to understand, hard to describe. It's hard to provide assurances. We still know that. But, and the current shift now, where does AI play a role in here? Well, it scales up opacity. So opacity is even much higher when, because of the transition by AI from automation to autonomy. We all know that, it's hard to understand why are certain decisions made, why are certain outputs produced. People talk about explainable AI, for example, okay, as a goal. Actually, I would talk about explainable software systems in the first place. But of course, AI even adds to this opacity, scales up opacity, right? Through the fact that, components are learned, they are not programmed. There are species of software over which there's no human intervention in terms of designing that software. They're learned. But again, I like history, and I like to point to something that actually people started thinking about this years ago, and sometimes we ignore that. So even the fact that complexity leads to opacity actually was in a famous paper by Fred Brooks, which the no silver bullet, which is has been a very highly cited paper for many years. Okay, in which he talks about this complexity that makes our systems so hard to understand. So what I'm claiming here also is that opacity is what favors concentration of power. So in the lack of other processes that define those rules, everything is actually managed by the big platforms which control technology. And, I'm talking about the big five plus one, actually, the Google, the Apple, Facebook, Amazon, Microsoft, and plus one, Twitter, X, or whatever you want to call. Okay. So basic questions. So we're directing our future. Our future is mostly in the hands of those. So the question is, we, the market, governments, technologists, none of them, all of them, for sure, it's not we. It's certainly the government. It's not the government. Sorry, it's certainly the market. Technologists, yes, but not we. When I say we, I mean we as collective, a body of citizens. But then the question is, can we direct our future? Shall we direct our future, or do we want to leave it in the hands and let it go? Driven by the market, the big ones in particular. So if not, what kind of principles do we need to refer to if we want to become, actors in deciding where we want to go? Which are the principles that we have to refer to? Well, my claim is that the principles are, many people, and I'm not going to give you a definition because there's no definition, but, a term that many people have been using, which is the notion of digital humanism. Notion of digital humanism meaning that the founding principle should be that humans have to be at the center and not vice versa. So humans should direct technology. It shouldn't be the other way around. So technology is for humans, not humans for technology. Not humans for the big five or the big six or the big seven. So how does this affect software engineering? Well, of course, in what I'm saying, you may say yes, but not all systems, have such a huge human impact. That's true. If you're working on tools, for the instrumenting the Java byte code, as we were discussing before, most likely not. If you're developing a new real-time operating systems, most likely not. But remember that the largest majority of systems that people build fall in a category that sometimes people call socio-technical. So they are technical systems that live in a social context. So interaction between people and technology in workplaces, in private life, well, all this, is key. And this is what defines the world that we're building, right? In addition, the technologies that we build also, they not only, as I said before, affect the relation, the social part, the relation among people, but also the way people think, but also they change the world in the sense that there's interaction with the physical world, which leads also to problems of sustainability, for example, of the solutions that we develop. So there's a dimension of responsibility which relates to humans, but there's a direction of responsibility which relates to what technology does to Mother Nature, to the physical world. For example, in terms of energy consumption, in terms of a carbon footprint, all this. Again, that's a responsibility that we have to assume, right? Okay, so digital humanism, yeah, exactly. So humans at the center on the one side, on the other side, sustainable relation with Mother Nature. And this is, what I believe should be the guiding principles for us. Let me try to position, our work, and by referring to a very classic piece of work that many of you may have seen in the past. So Michael Jackson and Pamela Zabe, two eminent computer scientists in the 90s, they were, they gave foundational contributions to an area that is called requirements engineering. Okay, and what they do is that, but I think it's a very deep paper actually. So they talk about the word and the machine. Okay, so we technologists, we build machines, but we build machines whose goal is to achieve something in the real world. So there's real world goals, certain requirements under which we build those machines. And goals and requirements are not technological goals and requirements. they're something that comes from the real world. When you develop a system, you try to solve some problem that is in the real world. Actually, so to do that, first of all, they say we need to understand the specific domain, the specific environment in which the machine is going to be deployed, understand the properties, make some assumptions on the behavior because we may not know it. And eventually what they say, if you want, that's the only kind of formal piece, the only formula that I'm using here. But, what they actually say is that the engineer's responsibility is to build a machine such that, this machine, based on the assumptions and properties of the environment in which the machine is deployed, entails satisfaction of those requirements. So our responsibility is understand the requirements, build a machine, understand the domain, okay, and build a machine such that in that domain will bring to satisfaction of those requirements. Okay, well, so if you look at socio-technical systems, as I mentioned before, goals and requirements express human societal concerns, values, and the context refers to humans, social relations. So, but traditionally what happens is that identifying, negotiating, setting, trading off requirements and goals is mostly done by people who are technologists, by software engineers. And what software engineers do is, and that's what we taught them, our fault, is to focus on functional requirements, things that you have to realize why. And a few non-functional requirements. Non-functional, mainly they are performance. Okay, that's what we have done so far. So the whole thing is largely driven by the objective of setting technical requirements and ignoring all the others. So human, societal, environmental requirements are often ignored or hidden or implicit. And what is worse is that these are what some people call unknown unknowns, which means that you don't even know that you don't know that those things are important. Okay? So there's no awareness. And you may say, that's fine, we are technologists. But so what I want to claim is that for most of the tasks, just being technologists is not enough. Another thing is that very often unanticipated additional satisfiable goals or requirements are ignored. So it's very rare that people ask themselves, if the system does this, can this be also used to do these bad things, for example? There's often a notion of potential dual use of those systems. Classic examples, social media, right? They can be used to do very good things, to bring together people, but they can be used also to do very bad things, to create echo chambers, hate groups, to spread fake news, all this. Was that considered as a potential side effect or additional satisfiable goal? And then, of course, the implementation is owned by software engineers. But what I'm saying is that there's a lot of, other things that software engineers decide, but they actually touch on issues that are not technical. So So as a result, we deliver systems where technical decisions have non-technical, sometimes unacceptable effects on people, society, environment. So what we do is that we do ex post patches. When we realize, but the point is that ex post patches are bad in this context. And the reason is that technology spreads very rapidly in society. So you try to solve the problems when the problem also became, big, because systems are out, people use them. So we have seen examples, privacy violations, unfair operation. We have seen systems that make racist decisions, that they're gender biased. For example, in the case of learned components. So the question is, can instead we address this instead of ex post, ex ante? So when we develop our system, why don't we try to anticipate those potential problems? So can we be better systems, if you want? That's the question. And what is better? What does better mean? Better system for a better world. Or if you want, so can we build systems that comply with these principles of digital humanism? Now, when you talk about better systems, better for humans, then you enter a discussion that is what people call ethics, right? Because ethics is, in fact, the branch of philosophy that addresses, the questions of, what is right and what is wrong, what is good, what is bad. And so we have to ask, questions that have an ethical implication here. But my question is, in the way, for example, we teach software engineering, do we ever raise the question when we develop a system, whether this is good or bad, whether this is right or wrong? As I said, I never did it. I have to say, I've been teaching software engineering for 30 years, maybe, and more. But when I was teaching requirements engineering, I was talking about the usual functional requirements, but never, addressing these kinds of questions when you design those systems. When you implement the system and assess alternative solutions, when you validate, verify your system, do you validate and verify with respect to those good and bad, right and wrong dimensions? So my feeling and my, hope, if you prefer, is that, in 2006 was the era of, where computer scientists said that others should learn from us and should learn from us the value that we have, which is what we call computational thinking. And in fact, we used to say that computational thinking should be part of the education of everybody. And I still believe that, because there's a lot of value in that. And there was a very famous paper, many of you have read this, by Jeanette Wing. Okay, what I'm claiming is that in the 2020s is the time to do ethical thinking. We have to bring ethical thinking into computational thinking. So that's the ethics. The reasoning about those dimensions and deliberations on ethics should be pillars of software engineering and practice. As I said, there's three, dimensions. The human dimension, we want to preserve human values. The societal dimension, so there is societal, and then the natural world dimension, as I said before. So I think that a first very important step that lead to taking responsibility is to try to make choices explicit instead of taking decisions in some kind of implicit way. So this is, I think, is one of the important things that have to be brought more into the way software is developed. So try to make the kind of choices that you have to make when you design a system explicit, and take responsibility once you have made them explicit. So I would guess that my hope is that we are moving towards ethical software engineering. Actually, I mean, there is a kind of widespread attention, more and more, to the issues around ethics. For example, both societies are taking this more seriously than they used to do it in the past. And the reason is that we all realize that technology is getting more and more every day closer to people. So that's why ethics becomes so important. There's this document by the IEEE about ethically aligned decisions. There's a code of ethics from the ACM. So there's there's professional standards coming out. Okay, but the point is that those documents, they are all not actionable. So they state a number of principles. What we need to do is to find ways that those principles can be. Sorry. I need water, but I can get to the end. So and to do this, what we have to do is to make ethical deliberation as first-class elements in the process of developing software. To do that, there's a number of questions that we have to ask. I will try to tell you how, what some people are trying to do here. But first of all, the difficulties are, so who should be involved? As I will try to tell you, is that not just technical people, but we need to build more interdisciplinary design teams to be able to manage those challenges. Grazie. The second difficulty is that when you're dealing with ethical questions, and this is very important, they almost never lead to clear black and white distinction between something that is certainly bad and something that is certainly good. Okay, there's a continuous, from black to white through the various degrees of gray. There's a whole continuum of spectrum of possibilities that you have there, meaning that the only way to address this is through, and this is what philosophers actually taught us, through processes of ethical deliberations that include people. And another question is, once those goals are defined, how you specify them, how you validate them. So first, who should be involved? I believe that for most of the systems that I've been talking about here, design groups should not only involve technologists, software engineers, but we need additional knowledge contribution from, depending on the system, but from other areas, from humanities, social, political science, law, depending on the domain in which you are. There's implications that software engineers don't understand. And it's, there's nothing bad in this. But the point is that there should be a common a discussion ground in which software engineers can talk to these people, and those people should be brought in the design process. So what happens is that what is needed is that there should be a collective process that identifies the goals and requirements, and this collective process is a process through which all the designers that are involved take their own responsibilities. Existing efforts, well, for example, there is I'm aware of 2 examples of groups that are working in this area. There's an interesting research that is done at TU Munich, and in particular at the Bavarian Research Institute for Digital Transformation, which involves this guy. Tretchner is a software engineer. Actually, he's the guy who took the chair that was Manfred Roy's. Manfred Roy. Software engineer and a philosopher. Mida Wimmerlin is you're German. The Germans saying that he's a very famous German philosopher. So they work together on a project that is called Ethical Software Engineering by Design. And what they are trying to do is that they are working on, let's say, designing an agile development method in which ethical deliberations are properly inserted in the process. There's another effort, Bashar Nuseibeh, many of you know him, at Lero. He has a project that is called Responsible Software Engineering, which is very much based on similar principles. So, in terms of research, what we need is to enrich the technical perspective with other perspectives that are context relevant: ethical, social, legal, political, economical. So in particular, in requirements, we have to reformulate, how can those ethical issues and stakeholder values be addressed in the software process? What are the best processes that you can follow? For example, agile processes look, promising and interesting as a way of organizing the production and in including those ethical deliberations. So agile or new forms of participatory design have to be found. In terms of verification and validation, how can we continuously verify and validate what we are doing with respect to those broader sets of values, ethical values? And also at runtime, if we build systems that behave autonomously, how can we make sure that there's continuous validation of those systems with respect to those goals? Continuous evolution, as I said, including, self-evolution, autonomous evolution. Yeah. So we need to fight opacity, and I think that there's still a lot of research that needs to be done to make software systems transparent, which is the opposite of opaque. So transparency is what is needed, really. We want to have systems that are transparent, systems that we can reason about, that we can understand as a prerequisite for relying upon them. So they had to be trusted at all levels by users, by designers, by policymakers, by regulators. And transparency cross-cuts all levels. As I said, today there's a lot of emphasis on making AI explainable. Explainable AI is a big, focus of AI researchers. But what I'm saying is that actually the goal is to make systems transparent in general. Also, if there's no AI pieces in those systems, and we still are far away, how do we make, so we need to have trusted different views of those systems that you can trust, you can reason about those systems. If you're a regulator, you're interested in certain views, but they have to be trusted, not fluffy views, right? So do we know them? Do we have notations, abstractions that are trusted, that can be used to make, systems explainable, transparent? Of course, on the one hand, it becomes, when you design a system, you can design the system for transparency. And this is a responsibility, but still, you need to be able to make, system transparent. Well, and of course, it has to be friendly, it has to be adaptive. It depends on who is interested in understanding that system, for what. So I think that this, there is still a broad area to investigate here, how to make, systems explainable, but through trusted descriptions, through trusted views, and they have to be customized depending on what the interests are. And in terms of education, how to educate professionals for the new world created by technology. For example, I'm still worried by the fact that all the design efforts that we in university propose to our students are to students who work just among themselves in a group of technologists, a group of software engineers, right? But then, we live in a university, and universities are, the best possible world in which you have, different people from different disciplines. You have from social sciences, from political sciences. Why not design experiments for those students? Why not challenge students to design systems in collaboration with those? Living in universities are living labs of the world in a limited and protected environment. But we don't use this kind of availability of different cultures. But here is an area in which, because those people need to understand technology. The people in political sciences and social science, they need to understand technology. So they also need, to understand what is going on in the new world. And of course, technologists are not the only ones who are responsible, have to be responsible for the, the designs. So why not challenge our students? I have to say that, I haven't done, when I was in the university. Perhaps, 30 years ago, it was different. The world was not as complex as today. Technology was not as impactful as today on society. But today, I think we need to do that. We have to break the disciplinary silos that we've been built around, our disciplines. And we live in the ideal place to do it, I would say. So make existing CS curricula digital humanism aware. I'm skipping. Yes, just to tell you, a little bit, the digital humanism, just to mention something that is dear to my heart, which is a something that this digital humanism. There's an initiative in which I am involved, and I will point you to something that you may be interested in reading or understanding more. This is a group that is called the Vienna Digital Humanism Initiative, and the reason why Vienna is because these people got together in Vienna for the first time, and I was, part of this, very initial group of people. This guy Wertner is from Technical University of Vienna. This is from University of Amsterdam. Edward Lee is from UC Berkeley. Moshe Vardi, you probably know who he is, and myself. So we met in Vienna and we launched this initiative. And this is the reference to this initiative. What happened is that there was initially a workshop, a manifesto that was written. It's public. You can read it. You can even sign if you believe in it. There's a lecture series. There was a very interesting 1-2 weeks ago. They are all online. If you go to this site, there's the YouTube channel. You can see the lectures that very good people, very top people have lectured in this series. And there's a book. This is the first book that we produced. Actually, it's a collection of essays from people of very different areas, from computer science to sociology, political science, geopolitical systems, and now actually this is all. Now I think it's about 700K downloads. So this book has been downloaded by an enormous number of people. It's not open access. But it means, I think that it shows that there's an interest around this theme. And actually, there was a summer school then. We do research, innovation, and education. A roadmap was produced, and a new textbook just came out. And this is called, again, Introduction to Digital Humanism. And these are the people who co-edited this book. So this aims really at being kind of textbook that can be used, for teaching. So that's the background, and I think I took a lot of time, probably too much, so I'm stopping here, of course. And I'm open to questions, disagreements, agreements, or comments, or whatever.